Hey guys, so this is day two's lesson, so I'm just going to add that on the top here. Just a quick recap. I know a lot of you were absent on Friday, and I also had a meeting on Friday, so I wasn't in one of the two periods. So I just want to go over again the two types of variables. We have discrete and we have continuous. Okay, for a discrete, the definition is it's a value that can be counted. A value that can be counted. Okay, so some examples could be like the number of runners in a marathon, the amount of phone calls you receive, anything that can be counted. Okay, so we can write the number of runners, number of phone calls you receive, it could also be the amount of Snapchats you receive. Okay, they don't have to say the number, but you can say the amount of Snapchats. All right, I can count how many Snapchats I get each day. If I were to have Snapchat, I could say, okay, I got 1, 2, 3, 4, 5 Snapchats from my friends. I can count that, so that would be a discrete variable. Okay, whereas continuous, it's a value that can be measured, not counted. So a value that can be measured. Okay, so in this case, you can't count it. Okay, and so what I mean by that, if we're looking at maybe temperature in a certain state, so like the temperature in Florida, can't really count the temperature, but I can measure the temperature, right, with a thermometer. The height of a building, okay, height would be considered something you can measure, but not count. And maybe like the speed of a car. Okay, again, you can use a speedometer, but you can't actually count the speed. Okay, so that's car. All right, on the bottom here, what makes a probability distribution valid? We talked about this in our previous lesson. The two things, first, the sum of all the probabilities has to be 1. Okay, so if we had our probability chart here, everything that was on the bottom has to equal 1 when you add them together. Okay, so that's what I'm talking about when I talk about probabilities. And the second thing, in order to make a probability distribution valid, is that all of the probabilities must be between 0 and 1. Okay, so there's no negatives and no numbers greater than 1. Okay, and that's including the 0 and the 1. Okay, you can have a probability of 0 and you can have a probability of 1, but if I have a negative number down here, or if I have a number like 1.5, that would make my probability distribution invalid. Okay, and if I flip over to the other side, I know we started doing this in class as well, so this is just a quick review for you. The probabilities that a randomly selected home has garage space for 0, 1, 2, or 3 cars, and then they give you the probabilities that correlate with the garage spaces. So first I'm going to take the 0, 1, 2, and 3, and I'm going to set that up on the top of my probability distribution. And then I'm going to put the probabilities right underneath as they correspond. So 0.20 would go right underneath the 0, 0.35, then we have our x, so we have to solve for that, and then 0.08. Fill in the distribution chart, which is what we did, and solve for the missing probability. So solve for the missing probability. Okay, in this case here, our missing probability is our x value. All right, and I know we spoke about how to find a missing probability. You're going to do 1 minus the sum of the probabilities given. Okay, so I know we talked about that a little bit. So we want to add 1, 2, 3 of the probabilities that they gave us. Okay, so 0.20 plus 0.35 plus 0.08 is what they gave us. And in this case, you get 0.63. If you do 1 minus the 0.63, you get 0.37, and that's going to be the missing value up here. Okay, in order to do the graph, you have to find the missing value first, or the missing probability. Okay, and this, anytime you're doing a graph that's a probability distribution, I call this my lollipop graph. I know you guys sometimes want to call it the flower without the petals, whatever works for you. I'm going to call it my lollipop graph. All right, on the bottom, we're talking about garage space and the number of cars. So I'm just going to label it number of cars on the bottom. And then on the side, we always want to write our probabilities. All right, in this case, the highest value, the highest probability is 0.37. So when we create our scale, we just want to make sure that we leave enough space to fit up to 0.37, and we also don't want it to be too crunched. So I'm going to start at 0, and I think I'm going to go up by 0.05 or 5 cents, right? So you want to get up to 37 cents. So 5 cents, 0.10 is 10 cents, and so on. I think it just makes it easier to count. And you could, again, you can go a little bit higher. That's completely fine as long as you have enough space to reach the highest value. And then on the bottom, I'm going to do 0, 1, 2, and 3. And I'm just going to skip a little bit of spaces there, but evenly spaced out. This way our graph is not crunched. At 0, you're going to graph 0.20. So you're going to make your little lollipop, as I call it, with a nice long stick. At 1, you're going to go to 0.35. Make your dot and your lollipop stick going down. 2.37, which is in between 0.35 and 0.40. Just do the best you can. And number 3 here, number 3, 0.08 is close to the 0.10. Oh my goodness, where am I putting this? Over here. Just making up my own spot here, not that one. Okay, so there is my graph. Okay, please don't look at that point. I'm incorrect there. I just kind of missed the 3. And again, if you are unable to print this for your independent practice, just sketch it on, a separate piece of paper, snap a picture, and then try to upload it through Canvas. You guys are doing a great job. We'll tune in soon. Bye.